Hello everyone, and welcome to part 6 of our Hackolade tutorial. For the past 2 parts of the tutorial, we've been creating our data models, right? First a simple data model in part 4, and then we were starting to create nested objects and arrays in part 5. And now in part 6, we're going to take it one step further and add advanced data types to our data models. Advanced data types like choice, conditional, or pattern fields. I should, however, say that this is technology and these are data models that are specific to JSON schema-based data models, right? Choices, conditional, and pattern fields are JSON schema-based capabilities that are not going to be available in all target technologies. It's really limited to the technologies that use the JSON schema capability. If it's not available in your target technology, then obviously the feature will be disabled. So let's start. We'll start with the choices, right? That's the first type of field that you can add to your JSON schema. It's a really interesting one because it allows you to combine schemas together, right? You can basically say, you know, I'm going to have a field here whose value will be validated against multiple criteria, right? Choice criteria. When you do that, you can also combine this with Hackolade's referencing technology, right, which allows you to pull in information from other models or other objects that you have stored in your library, and thereby combining schemas, assembling schemas from multiple files depending on the choice that is made. So therefore, this is actually a great way to implement something we call polymorphism, the capability of a JSON document to take multiple shapes. It's a great way to deal with changing requirements and evolving and flexible schemas, both at the document structure level and also at the field level. You can implement this at a variety of different levels, thanks to the nested nature of these types of documents. So one great example is that a field in your document can either be a string or a complex subschema. We'll go into that a little bit later on. That way you can combine the schema of multiple documents into your particular environment. The choices that you have as part of JSON schema are one of the 4 that you see here on the screen. Right? So all of, or it's basically an AND condition, means that the constraint must be valid against all of the subschemas. Any of means that the constraint must be valid against any of the subschemas. Or one of means that exactly one of the subschemas must be valid, XOR. And not obviously means that the constraint must not be valid against the subschemas. A great example, and we'll go into that in the short demo after this, is an example of polymorphism is a shipping address. Right? You've probably seen this yourself in many shopping cart applications where you can either say, okay, my shipping address is equal to my billing address, or it is a separate address. And that's exactly what you see here, right? So you have a document that is representing a person, right? A first name, last name. That person has an address, a billing address, right? With a street name, house number, city, and state. And then here you have a choice field where you can see that the individual in this document can either have a string that is selected as the shipping address, which basically means it's identical to the billing address, or you can say it's actually a completely separate address, right, with a completely separate street name, house number, city, and state, right? So that's the way that you can do this. And before we continue, I will actually take some time now to show you how this is done, right? How you can implement this in the Hackolade Studio. And so we're going to switch to that part of this tutorial right now. All right, so let's show this. I've got my little model right here where I have a document that has a first name and a last name already set up. It also has an address document in there already. What I'm going to do now is I'm going to basically expand this because I've already got a billing address pre-configured here, and I've got it converted into an internal definition as well so that I can easily reuse it. And I'm going to now say, okay, I'm going to have a choice capability for a shipping address to be added to this document based on the choice of the user, right? So in both cases, it's going to be a shipping address, but in this case, it's going to be a string, right? It's going to be a string that is going to basically say, okay, this is my shipping address. And in the other case, it's actually going to be something completely different, which is it's going to be a full-on address, right? It's going to be an address that I'm going to choose from an internal reference here. Right? So now I have a completely separate structure that I've added here based on the internal definition. So as you can see here, now I've got the two options, right? Either the billing address and the shipping address are the same, that will be indicated in this string over here, or the billing address and the shipping address will be separate and they will be of the same structure. They will be completely similar structures that are now also defined in my JSON schema. Great. With that, we're going to return to our presentation and continue with the next specific case, which are conditional fields. Conditional fields are interesting because they allow for the application of a subschema depending on the outcome of another schema, right? They're also interesting because they've also been misapplied quite a few times. They are not intended to be used for multiple data types as part of your JSON documents. It's a very different application. Multiple data types can also be implemented, but using different parts of the specification. The conditionals are really these if-then-else statements that you can specify, you know, what has to happen if certain conditions are met or not met. A great example of this is, for example, choosing the format of a postal code, right? So every country has its own different way of formatting the postal codes, and depending on the value that we find in the country field, we would apply a different format to the postal code field that is also part of this document. So it's really easy to apply this in Hackolade, and we will show you that in a minute. So let's switch right over and show you that immediately. So here we go, we've got our little demo document right here, which is going to illustrate my conditionals. I have a country string right here, a field that is a country string. I have a street address here that is also a string. And now what I'm going to do is I'm going to have a new attribute, which is going to be a conditional attribute based on the value of the country, right? So if the country has a constant that is equal to USA, then the postal code, right, is going to have a particular pattern, right, which I'm going to copy in right now, right, and that pattern is going to be equal to this, right. If it's not the country equal to USA, then I might have a different type of postal code, which I'm going to paste in over here as well, right, and that's this pattern over here, and I have this name here as well. So you see, this is how you can implement these conditionals really, really easily, thanks to the visual JSON editing capabilities of Hackolade. You can obviously also immediately see that in the preview here, right? So there is an if statement here, then else. I know all of that is very, very easily accessible right in the Hackolade Studio. So with that, we're going to switch to the last part of our tutorial here, which is all about pattern fields. So let's talk about pattern fields. Pattern fields function in exactly the same way as standard fields do, but there's a little bit of an exception. The name in the name value pair is not a fixed string, but it's actually a regex pattern, right? As you can see it over here on the screen, right? So the followers that you find here in the pattern example, right? ABC123 and ABC789, you know, these are actually variables that you will be able to use in the pattern field, right? So pattern fields are typically controlled by a regular expression, right? So that's why it's called a pattern field. And you shouldn't look at it as a field name, but rather look at it as a key to a subdocument when embedding something in that document, right? It lets you easily access the right subdocument inside an array or a main document using the dot notation. Right? So this is the way how you can do that, right? And I'll quickly go over some of the mechanisms that you have inside Hackolade to efficiently add these structures to your JSON document. Let's go there. So here we have our little document, right? The pattern example with the followers in there, right? And what I'm going to do now is I'm going to go into the schema of that of those followers, and I'm going to add a pattern field, right? I'm going to add a pattern field that is a document, right? And that document is going to be composed of a field that has a string, the name, right? But it also is going to have an array, right, over here, right? And that array is going to be the sports of those followers, right? So now we have the structure that we wanted, right? So we have followers that can are accessed with this regex-based identifier. Then you have the name, and then you have an array with the string, just like we had it specified in our example over here. So with that, I'm going to wrap up our sixth part of the Hackolade tutorial. I invite you to look at some of these reading materials that you see here on the screen. I hope they are useful for you, and then you can obviously also refer back to some of the questions that you find as part of the tutorial as well, and hopefully that will be useful for you. I wish you a wonderful rest of your day.